Good evening, sir.
Yeah, good evening.
Good evening, sir. Good. Mm,
Good evening, sir.
Yeah, good evening, everyone. Uh, we have a little less participation, but
Good evening, sir.
I think we can start. Okay, so uh, this is just a brief what we are going to cover. I will cover all of this details. So now, now you are done. A little bit exploration with the data, so you are able to see describe the data, right? Descriptive part of the data you completed that. Now you are about to go in a inferential part, how to make assumption from the data, how to make inferences. Basically. So to make assumptions or inferences, you will require probability. That this might whatever I'm saying is somewhat I am this much accurate. Okay, some this percent accurate or something. So that to make that uh, statement, you need some amount of probability. Okay, so there is not surety in that. So to learn probability, first we need to learn this permutation and combination, how to count things and all. Okay. So for that, this uh, session is there. So I'll cover that. So what we are going to do today in today's session is we will understand what are basic principle of counting, what is like uh, addition rule or or function. So wherever conditions are like A or B, then count. Uh, so what will you do? You will add them, and so that is basically. So I'll explain that. Multiplication rule when you say happening A thing and also B thing. So that is like multiplication rule. Okay. Uh, then we'll see how to arrange items. So we have, let's say, n item, distinct item. Okay? Distinct means different item. So let's say if you take books, uh, then let's say you have four books: history, mathematics, physics, chemistry, some. So all are distinct things, okay? And you want to arrange them. So arranging is like, let's say you have bookshelf, you have to keep them, right? So that is like arranging, and you have to arrange all of them. So for now, I'm taking all the items and arranging them, okay? Arranging n items, uh, like that. So any number, but you can arrange them. And for arranging, we'll learn how to use factorial in that. If you want to arrange something, how to use factorial. Okay. Then we'll see how to arrange items, but now they are not distinct. Okay. So let's say now you have let's say books are there, but same book. Okay, same book. Something you can say. Let's say two history books are there, five chemistry books, four physics book, and something like that. So now they are not different items. Okay, they are equal, like same thing. Okay, so then what will you do? So we'll learn factorial, how to tweak with the factorial, and uh, you maybe get the idea that this kind of formula will come up. So we'll see how to expand that. What is that? What does it this mean? Then so it was earlier we are talking about linear order. Okay, so they are in one line. You can say in a line like this. Okay, not in uh, uh, any other arrangement or something. Okay, so they're like one after another. Now there is something changes when you have such circular order. So if you want to arrange, let's say like this is round table is there. How many ways? How many ways you can arrange things? How many ways a person can sit or something like this? So for that, there's formula like n minus one factorial, and we'll cover that. And then like this is separate, not in this. So it's a different one. If you have this kind of question, like what does this mean? Like n factor by k factor. So it will basically this and this could come together or something like that. You can say. Uh, I mean, how to navigate with factorial. This is just mathematics where to use in solving the equation. Okay, so it will help something like that. Then so this combination is not there in this week. So fifth week it's not there. It's in sixth week. But nevertheless, I'll cover it because it's it depicts one very important factor of uh, choosing the items. Okay, so let's say you have earlier you had items, right? N items, and you are arranging them. You aren't doing anything. Total all the items you are arranging. Okay, now the question little bit differs. Now they are asking that how to choose items. Okay, we are not arranging. Very careful. We are not arranging. We're just choosing. Okay, so that's what we'll use combination. Yes, and combination formula goes there. We'll go in that detail. Then now permutation comes, which is in this term. That's why I kind of wanted to explain combination. Choose and arrange. So now you want to choose the items and then also arrange. So and is very important, and arrange. Okay, not or, and very careful that and is there. Okay, I'm focusing on that. So choose and arrange some items are items, let's say from total n items, then we'll use permutation. Okay, so you got that, like choosing, and then so this multiplication rule which we learned here. Okay, we're like, I mean, we are about to learn, but this is something we'll start with. So this multiplication rule still holds here also. So since I had said and, right, so this is like choosing and arranging. Okay, so that way we'll learn permutation, and the formula is like this. So we'll go into formula and all everything. So we can start with first basic principles of counting, how to count things. So let's start. So we'll go with basic principles of counting. Okay, of count. Now, now let's say uh, let's say you want to uh, take a bus from a bus stand. Okay, so bus stand is there, and you want to take a bus. There are like let's say a route is there, and there are six available buses. Okay, six buses available, same route, same thing, nothing difference. Okay, I mean, like the buses are different. That's all. So if I ask you how many ways you can go to the another stop. Okay, so let's say this stop to this stop, stop two or something. This is stop one. So some. So there are six buses available, which goes in same route. Okay, same route is there, six buses. So in how many ways you can go it? Then you'll say, okay, so I have six choices. Then I can go all the way. Right? Six buses. It's the same thing, nothing different. Very easy. Okay. Then let's say there are like two routes. Okay. Now there is like here we had only one route only available. But now we have, let's say, two routes. Route one. Uh, okay, I think okay, route one. Also there is route two. Okay. Yeah. See, now the only confusion which you will always come across is, I'll say we had no, see the word wise English wise, I'll say we have two options, route one and route two. But but the catch is you don't need to, you'll not multiply, you'll add them. Because either you go with this route or this route. The options and the things you are gonna do in real life is different. Okay, so either okay, I'll say very, either you are going to go with route one. Okay, or you are going to go with the route. Okay, either route two. So this is like or, this is or, uh, and you could have understood this is addition rule. Okay, addition rule as well. So let's say in route one there are like seven buses are there, and in route two, same location, okay? Destination is same. So this is single destination, and this is like there are like, let's say, five buses goes in route two. Now if I ask you how many ways you can go, so you kind of get that. Okay, I have 12 options here. If you see, you have 12 options in the beginning, and so this is like 7 plus 5, 12. You can go this, right? Uh, this is like something. Okay, now this addition to. Now let's say you have this is, let's say, my stop one. I have stop 2, and there is another thing, stop 3. Okay. Now let's say from stop 1 to stop 2, there are like 6 ways you can go. Okay. 6 ways. Or let me take this one only. It says same number. There's just nothing. Then from S2 to S3, you can go in 5 ways. Okay. So or some 5 buses, 5 bus ways, everything the same. Okay. Bus something. So like that. You have it. Now I'm asking you have to go from S1 to S3. How many ways you can go? Okay. How many ways you can go from S1 to S3? So see now what I'm doing actually is I'm going S1 to S2. I'm going and I'm going S2
Hello,
to S3.
hello, sir.
Okay.
Can you hear me, sir? Hello.
Yeah. Hello. Yes.
Sorry to disturb, sir, but your voice is a little bit jittering, sir. It's not completely audible, sir. Can you please fix your mic, sir?
Sorry, bro, it's audible to all.
No, no, there are many
So
students,
there
sir.
has been a problem since the start,
It's
sir. His
not
head
it's
shielding is
not
right.
sir very clear. It's
Then
not
you
very
Yes,
should
it's
clear.
not.
join again.
It's not very clear, sir.
It's clear,
Okay.
bro.
Yeah, I'm not sure. I mean, see, for few it is clear, for few it's not. But
No, sir, the
uh,
voice is
Clear only, sir. Clear, sir.
okay,
It was clear.
okay,
It was unclear to me, sir. And I left the meeting and rejoined it. It was clear to me, sir.
No, sir,
okay.
not completely clear. It's somehow
Okay, I will.
See, I think, see, from my side, if it's clear for few and not clear for few, then it's like problem for your side. I think that okay. If it's problem for all, then or majority, then I could say that mine it's a problem for my side.
No, sir,
So I
it's
think
not a problem.
you can maybe rejoin or something you can do. Okay.
I
Uh,
can hear you clearly, sir.
yeah. Thanks. So
Okay,
if
so
you
you
have
can
problem,
continue. We'll let you know.
yeah. Yeah. Okay. So okay. See, we'll start. I explained addition rule. Okay. Yeah. I was about to explain multiplication. So now see the task we are doing is we are S1. We are going S1 to S2 and we are going S2 to S3. Like I'm not going directly to S3. Okay. Just in way. But I'm asking how to go to S3. These are the only possible ways. So now from here to here there are 7 ways, right? 7 ways, and is like multiplication and 5 ways. Uh, so the total will be 35 ways you can go from S1 to S3. We can see that also. See, let's say from S1 to S2, uh, you went by let's say bus 1, bus 2, bus 3, bus 4, bus 5, bus 6, okay, and bus 7. Okay, so 7 buses were available. You can choose any one. You reached S2. Okay, now you reached there. Now from S2 you always have 5 options, right? Always like you reached S2 and you have 5 options. So like let's say from S2 I will say let me say small b. Okay, small B1, B2, B3, B4, and B5. Okay, from you reach through bus 1 and you reach S2 and now you want to go S3. So you have 5 options. You reach S2 from using B2 bus, but still you have 5 options. You use B3, you have 5 options. So like I'll say like you took B1 bus and you have 5 options. You took B2 bus, then again you have 5 options. You took B3 bus, then 5 options. So likewise, if you go till B7, you always have 5 options, right? So you can add them, and that is like 35. And you kind of get the idea that if you go this way, if you solve this way, then it is very uh, elongate, like very long, right? So the easiest way is like how to use multiplication. That's why it's that is like multiplication. Okay, so this is multiplication. Okay, so when you get a question that choose this or this, do something like okay, or when you hear or, then don't think too much. It's about addition. Okay, it's about addition. When you hear and, that do this and do this. So see, the end is very important, that I do task one, I complete my task one, whatever it is, then I go to task two. Okay. then like after this only I go. If they are happening simultaneously, or I can do like I can do all together, uh, then I can't use AND. Okay, something like that. So then you have to use multiplication. Okay, whatever ways are there. So this is very easy explanation of like what is addition rule and multiplication rule. Okay. So
When do we have to use or?
sorry, which one?
When do we have to use
Or
or addition? I understood that and should be used when there is in sequence, task and task in sequence. And when do we have to use addition?
so when you have see you can do T1 or you can do T2. So basically there's no dependency, you can say. Like let's say T1 you can do independently, and T1 T2 also you can do independent. And so those are the like we took here example. See, I can take either root one, okay, or either I can take root two, okay. So there is no dependency, right? Any root I can take. So this is like or I am adding them. But here, let's say I took S1 to S2. Until I reach here, I can't take this any buses. Okay, I can't take any buses. So there's a dependency. It's not independent. So I mean, I don't want to take these words, but simply saying this one task you do, then you do another, that is multiplication. Here you can choose any one you can do. So that's like or function. Okay.
Yes, sir, understood.
Yeah.
Sir, I have a question in this.
Okay. Go ahead.
Sir, like there will be only two conditions like T1 or T2, and there will be no T3. Like if we are doing like 4 or 5 different conditions, will there be such thing or not?
Sorry, can you repeat again?
Sir, I'm saying like sir T1, sir, in condition or there are only two conditions like T1 or T2. There can be like T3 or T4 or T5, something like
Yes,
that,
yes.
or so there can
Yes,
be.
sir. Yes, yes, there can be any. So this is just the example, right? You take root 2. Let's say there are root 3 also available. Let's say there is root 4 available, root 5 available. Then you can add all of them. So it's
Okay,
not
sir.
about two things or three things. It's about
Okay,
the
sir.
logic that are they happening uh, are they happening like one after another, or they can happen uh, independently also.
Okay,
So
sir.
it's
Thank you.
about the logic. So it's not about the number, like two things or three things. It could be anything. Okay. So
Okay, okay, sir.
or any n numbers, I can say Tn or something. Okay. So something like that. Yeah. Next is I think okay. Yeah. We have factorial or arranging the items. Okay. So let's say you have three books. Okay. I'll take three, then we'll move on to maybe take five books. Let's say one book is history. Another is, let's say, I'll take physics. So this is a subject name, and one is mathematics. Right? I have this three book in with me. So one important thing I'm saying is this are distinct books. Okay. So basically, what is not distinct is, as I had this books history book, same textbook. Okay. Then one mathematics book. This is not distinct. So we'll see how to do that, but to make very clarification that I'm talking about distinct. And whenever you see the question, you should also think that is it distinct or not. Then you should go ahead and apply factorial. Okay. So this these are distinct books. Now I want to, let's say, arrange in a bookshelf. So I have a bookshelf here with me. I can arrange them like uh, something like this. Okay. So I'm arranging the books in the bookshelf. Okay. Now I'm asking how many ways to arrange the books. So one clear thing, another clear thing, I'm taking all the books. Okay, so I'm not making any choices or anything. I have to take all the books and I have to arrange them. That's the simple task. Just whatever you have, arrange them. That is the thing. Okay. Uh, so we can do so I'll just write how many ways we can do it. So let's say I take first history book, then I arrange physics and math. Then let's say again I take first I keep history book, I arrange maths and physics. So I can arrange them, right? So this is a different arrangement than this. Okay. Then let's say I go and pick physics as first book I want to keep. Then I can arrange this way, PMH. This is another way. And let's say I keep math as first one, and then choose P. Okay. So it's very easy. So this is like 6 ways. Total 6 ways I can arrange them. So see one thing to notice is I can't repeat. In this case, I can't repeat. Repetition is not allowed. Something like this. Okay. Can't repeat, or repetition not allowed. Something that you can say. And another thing is, since these are real things, like things and all. Okay. I'll see when we'll go to numbers that you can maybe repeat as well. So one can come 2 3 times, something like that. So I can't repeat. And another thing, I have to arrange all the items. Okay, I have to arrange all the items. So that is also the case. So in that cases, we use factorial. Actually, what I did is I actually did factorial. Factorial is being represented like this. Okay, so you have n is a number. In our case, let's say here it's three, because we have 3 items. Okay, and we take factorial of this. So we denote it by what do you call this? Whatever you call it. Yes, I forgot.
Exclamation mark.
Exclamation. Yeah, exclamation. Yeah, so exclamation. Something that you can say that. So this exclamation mark. Okay, so this is how we denoted this factorial and all. N factorial, you would have seen it. So but okay, but what it is? So this is like you take n, n factorial is equal to n you take, then you multiply with n minus 1, then you multiply with n minus 2, and you go till like last number is 1. Okay, so let's say if I show you for 3 what it is, it's like 3 into n minus 1 is 2, then n minus 2 is 1. So since we reached here early, so it's like if you multiply this, you will get 6. Okay, let's say I do it for 5 factorial. 5 factorial is there, then like 5 is there n, then 5 minus 1 is 4, 5 minus 2 is 3, then 2 and 1. So this will be like 20 multiplied by 360, 60 multiplied by 2, 120. Okay, so something like that. So let's say I would have asked like arrange. I have 5 books now. Let's say history, physics, math, which were earlier my books. I have 2 books. Let's say chemistry is there, and let's say biology is there. Okay, so I have these 5 books, distinct books, and I want to arrange them in a bookshelf. Okay, uh, so how many ways I can arrange them? So since I have 5 books, I'll say 5 factorial. Okay, so that is like 120. I can arrange them 120 ways. You can write it, but that's very difficult. See, I can show it for one case. Okay, I will show you for, let's say H is there. H is my first one. That's HPMCV. Then HPMBC. I'll see if I can write it or not. Uh, so the point is, as say here we had very small number. That's why I could able to show you with writing. But when this is like 120 ways, right? So to write this is very difficult, and that's why we need this formulas, factorials, and all. Okay, so uh, okay,
Sir, but
yeah,
this formula only represents, sir, how many times we can arrange these book, right? It can't
yes,
like show us this way we can represent or something.
sorry. So this way represent.
Like so the formula just tell us the number of time we can represent, not the way how we can represent.
Not the
Hello?
way. Yeah. Not the way. It will give the count. Yes, definitely. It will. It will not give you anything like this is, let's say, one arrangement. Then how to write another arrangement or something. It will not give you any hint to how to write this arrangements. Okay. So yes, it's like you will have the count of in how many ways. So ways or you know arrangement. what are the arrangements. So you might hear these words, okay? Arrange and base and all. So whenever you hear arrange this 5 things or arrange something, so uh, that's where you'll use factorials. Okay. Now, okay, distinct item and all. Okay, this was factorial. Now, yeah. Okay. Now, what will happen if I have repeating things like not distinct. This was distinct. This was the case with distinct items. Else I have uh, not distinct items. Let's say I have history books, 2 history books. Let's say 3 history books I have. Then I have like physics book, 2 physics book, and let's say 1 mathematics book, something like that. So I have this total 3 plus 3, 6 books. Okay, total 6 books. Yes. Okay. So I have, let's say, 6 books now. Okay. Now, how many ways I can arrange 6 books?
6 factorial by 3 factorial into 2 factorial.
Okay. No. Okay. Let's say I have 6 distinct items. How many ways I can arrange them is 6 factorial. Okay.
6 factorial.
Okay. 6 factorial. Okay. But this is not the answer, right? Whenever you have repeating things, what you have to do is, let's say this are repeating 3 times. So you have to divide that by 3 factorial. Then this, let's say, repeating 2 times, I'll write 2 factorial. Earlier, since we had all the individual numbers, so I didn't show you, but inherently the 1 factorial is always there. But since 1 factorial is always 1, and its multiplication doesn't make any difference, so that's why we remove it. Okay. So if you write 6 factorial, that is like, so 5 factorial, I know 120. I just solved it, and I know that this is 6 times 120. Okay. That is 6 factorial. Then this is with the 3 factorial was 6, and 2 factorial is 2. Okay. Yeah. So this and this can go away. This is like 60. Okay. So answer is 60. I can arrange them in 60 ways. So whenever I don't have distinct words, then like this. Okay. So let me take an example. Let's say I have alphabets. Alphabets like, let's say, G, R, P, H, A, something. Okay. So these are just words. These are just letters. You can say something. In how many ways I can arrange them?
5 factorial ways.
Okay, 5 factorial ways. Okay. Now let's say I have another. So you'll come across that you have this word and arrange them. Okay. So let's say now I have something repeating something. So let's say I have what be that? Let's say I have book. Okay, book is there. Now I want to arrange the letters of this.
4 factorial by 2 factorial.
So that is like 4 factorial, since this is repeating, right? So I'll divide by that. So let's say now I have another word is like, let's say, statistics. Statistics. Okay. How many ways to arrange them?
10.
10 ways.
10 factorial by 3 factorial
Okay.
into 2 factorial into 3 factorial.
Okay, so I'll explain. Okay, this one I'll explain. So let's see how many counts are there, because we need it, right? So let's say how many S are there. So 1, 2, and 3. So 3 S are there. Then let's say T are 1, 2, 3. 3 T's are there. Then let's say A is there. A 1. Okay, only 1. Okay. Then I have I, which is 1, 2. So that is like 2. Okay. So if you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10. Total 10 alphabets are there. And I have here 6 plus 6, okay, 9. 1, what is missing? C is missing. Yes, C is 1 there. So if you total this is 10. So I know that all I have counted here. Okay. So this way I know that the ways to arrange 10 items, distinct item, is 10 factorial way. And if they are repeating, I have to divide by that. So 3 S is repeating 3 times. I'll write 3 factorial. The T is repeating 3 times, so I'll write 3 factorial. A is repeating 1 time, so I can ignore it. Okay, so this is actually multiplication in between. So just in case you don't know, this multiplication. Okay. Yeah. Then I is 2 times, so I'll write that 2 factorial, and I'll just skip the C part. So this like you can say let's say 10 factorial. Then I know the 3 factorial is 6 from previous thing. Like see, for few you can remember. I think I remember till 5 6 I remember. Then I don't remember. So this 3 into 2, this very easy, 6, right? 6 into 6 into 2, and this is like 10 into 9 into 8, and like that 7 6. Okay.
Sir,
Yeah.
sir, here we are using multiplication. So does here that means dependency also involves here?
No. I mean, see, this is if you merge that, then I think you'll have confusion. Okay, so don't merge that. I mean, see, here we were counting things, right? Like you used to count in your school time, like in previous years, like there's a 1 2 3 like that you used to go, and that was counting things. Okay. Now we are arranging things. We are not. Um, we are kind of counting, but we're counting the arrangements. So now it's become very difficult to get a hold, but uh, don't merge it. I mean, that's what my suggestion is. I'm not sure if uh, they are dependent, independent or not. But I don't want to go into that also.
Okay,
Very specific. Otherwise, I will also get confused later on when I will solve the question.
okay,
So
sir.
yeah. So let's say then I said okay. Then I have like 6 into 6. So let's say this could go away. This C can go away, and it flips 2 and 2 4. So I have 5 factors here. Okay. Then 4 could be like 2. So I have the 10 into 3 into 2 into 7 into 5 factorial. Okay. So you can solve like let's say this is 120, and this multiply 10, so 1200 into 7 6 are 42. So 42 into 1200. You can probably do this. Okay. So like 42, let's say 12 by 2, then 84 and 42, like 401,504, and then multiply by 100. So that is like double zeros. Okay. So this many ways are there. You can arrange a word like this. So if you have repetition, then you know, right? Now, yeah. So one important point is, let's say 10 factorial was there, right? So what I did is I tried 10 into 9 into 8 into 7 into 6. Then I wrote 5 factorial. So you can do this way also. So sometimes later on we'll learn that combination and permutation. That formula will help you doing this. So just remember that we can expand in any way. Let's say I can expand 10 into 9 factorial, or I can write 10 into 9 into 8 factorial. Okay. So it's any different ways I can use this. Whatever number I wanted, I can extract that using this, and then put factorial for rest of them. Something like that you can do. Okay. Uh,
But the
so
main is like we have to go until 1, right? Like 10
yeah,
into
go
9.
until 1. Yes, definitely go until 1. Okay. Yeah. Another thing about factorial is there is another case which is 0 factorial, which is 1. Okay. So 1 factorial is also 1, and 0 factorial is also 1. So uh, okay, this is in terms of reference, it's like very difficult problem till date. Like why this is 1. Okay, many have this question, and it's also always. So how I see, I can explain you with one analogy, but I can't prove it. Okay. Yeah, I can explain it. So how I see arrangement is, let's say I had 3 books, physics, math, and biology, or let's say physics. Yeah, I had physics and math. Okay, something like this. So how I see arrangement is, I take picture of it. Okay, so let's say this arrangement I made, and I take a picture. Then I made another arrangement, let's say this, and I take picture. Okay. So likewise, I have maybe three image. Then let's say M is there, MHP, then MPH, something. So this so six arrangement I have. I take individual. So this is my picture one, picture two, picture three, picture four, picture one, picture six. So I can take such picture. Now zero is like you don't have anything, like empty, but you still can take the picture. Right? So you can still take the picture. So how many picture you have? One, right? So something like that you can say like nothing, but you can take picture. So that is like zero factorial. Okay. This is the analogy. I'm not proving it.
Is it important for exam point of view?
Zero factorial.
Yes, sir.
Not sure, but it will come in many places. It might come.
Okay,
I'm
sir.
not sure. Okay, so zero factorial is one.
Sir, it can be proved also, sir.
Yeah, you can prove it. So that's different, but I don't want to prove it. Okay, I'm just giving you analogy that how zero factorial is one. Okay, you can
Simply
prove
say
it.
n into n minus 1, it will come 0 factorial equals to 1.
Yeah, sure. Okay, so that we had. So we see how to counting principle. Okay. Uh, Principles. Then we see factorial, or I would say distinct, how to arrange distinct object, arrange and distinct. Uh, then if you don't have distinct, then like you can say n factorial by something like so. Group 1 factorial, group 2 factorial, and group 3 factorial. So this is like when you don't have uh, distinct object, you have some okay, not distinct.
Repetition.
Yeah, repetitions. You can say repetitions. Okay, repetitions and all. Okay, so okay, now yeah, so one few questions will come across is, let's say you have 8 factorial divide by 4 factorial. So I mean that's what I was meaning by how to solve n by k factor or something, right? So you got the idea from previous, like 8 into 7 into 6 into 5 into 4 factorial, and I can do like 4 divided by 4 factorial, and factorial can go away. So this is what I mean by how to do this. You might come across this. This will come handy when you will go further. Okay. Now another arrangement is coming. Now that's, let's say here earlier I always talk about distinct object and linear. Okay, they are in linear order. I want to arrange them. Now they are in circular fashion. Like I want to arrange them circular order, you can say, or arrangement. Okay. Things like that. Then what should I do? Uh, so whenever you will see circles and all, so to arrange this, you can do it in n minus 1 factorial ways. So previously you can able to do it with n factorial, but here you can do it with n minus 1. So let's say you have five object or items, you can say distinct objects, then you can arrange them in 5 minus 1 factorial. So that's like 4 factorial. That will be 20. Okay. And what if they are not distinct? They are repeating or something like that. Then you can say like n minus 1 factorial divided by the bottom part will remain same, like g1 factorial, g2 factorial. Okay. So g2 factorial. That will remain constant. So just in case. So
Sir, can you give some example of circular order arrangement?
yeah, definitely. See, okay. Let's see. Let's say I have the circle. I have three school kids. Okay, three school kids who maybe want to sit for lunch or something. Lunch. So there's a circle table. They want to set it. Okay. So let's say different kids, definitely, right? So let's say kid one set here, uh, kid kid two here, and let's say kid three here. Okay. So something like that I have now. Okay, how many ways I can do is like 3 minus 1 factorial is 2 factorial. I can only arrange them in 2 factorial ways. So that is step 2. Okay. So okay, let's see. Now what would be the another arrangement is I can make K1 set here and K3 here and K2 here. That is the yes. Yes, that is the only way I can set. Okay, so in this case, one important thing is we see clockwise, like clockwise we see, and like anti-clockwise or something. Okay, so if you go clockwise, then you'll see that here K1, K3, K2 and K3 is there, and in this case it's like K1, K3 and K2 is there. So you can try. There's no other way you can arrange them. Okay, so what I mean is, let's say in previous case we had K1, K2, K3, and then K1, K3, K2. Then like let's say K2 is coming here, and like I do K1, K3. If you see this case, K2 is here, then let me take a clockwise way. Okay, clockwise. I'll go and see. So let's say K1 is there. If you see this one case, okay, uh, K1 is there, then K2 is there, K3 is there. Okay, this case K1 is there, K3 is there, K2 is there. Now what about this case? K2. So K2, K1, and K3. So if I start from this one, okay, this option, you can see that is satisfying from here, like in clockwise direction. If I go K2, K1, and K3, right? If let's say if I write K2, K3, and K1, then you can see here it's that condition is satisfying. So if I start from here, this point, and I go clockwise, K2, K3, and K1 is coming up. So it's not different, right? So this and basically what I mean is this picture and K2 then K1, K2 and then K1. Yeah. So this uh K1 and look, this picture and this picture. So I'll maybe put squares here. So this two pictures are same. Okay. K2, K1 and K1, K2, K3, right? This two pictures are same, and let's put in triangle here, and this two pictures are also same. Now let's say the third case is there. Sorry. Hello. Okay. So let's say K1, K3. Oh, sorry. K3 is there, and then K1 and K2. K3 is there, K2 and K1. Now, which is this? K3, then comes K1. So it's this one, right? This one. So let me add which one I choose for this square. Okay, so square, and this one would be from triangle. So you can see there are two different variation available in this. Okay, 3 factorial. You can go and try with 4 factorial and maybe draw this, and then go maybe clockwise and all. Okay, then see how it is. Okay. Now okay, so here see here we had distinct object, like we can't go in any something way, right? So whenever you see not distinct or something, let's say same things are appearing. Now let's say K1 is there, and now I can pick 2 kids or twins or something, but let's say I have a cube. Okay, cube is there. I'm keeping cubes in the like around the circle. Okay, boxes. You can say boxes or something. Boxes I'm keeping around the circle. Um, yeah. Okay. So let's say I have chairs. Okay, chairs are there. So there are like 2 kinds of chairs I have. One is uh, one is say triangle chair. Okay, let me take triangle chair. And one is let's say square or square chair. Okay, I'll just use this diagram. And let's say I had 2 square chairs and one triangle chair. Okay, now let's say I have one triangle chair here. I kept here, and I'm putting 2 square chairs. in this way, what's happening is now we don't have distinct items, right? Distinct. Like in previous case, earlier we had distinct but not distinct. This is not distinct. So like we did what we did, factorial divide by whatever number is, right? 2 factorial or something. So in this case, if I go from here or go from here, this both will look similar only, right? You'll not make any difference. Let's say if I go clockwise, uh, okay, then you will have triangle, square, and square. If I go anti-clockwise, then you will again have triangle, square, and square, right? Uh, so if I maybe mention which I'm talking about. So let's say I'll call this as a 1 and 2, but they are same, okay? They're exactly similar looking. So then if I go clockwise, it's like 1 and 2, and this is like 2, and this is 1, okay? But from outside, let's say I show you the picture, and I tell you that can you tell the difference? Then you will say no, I can't tell you the difference. So in this case, what happened is what we did. One was first with this n minus 1 factorial we took, okay, to find the number of ways, and then since we had like same in both ways, so we did divide by 2 factorial. So it will become 1 only. Okay, you can try with 4. Let's say I have 4 items. Maybe as a triangle is there. Okay, so let's see how many we can get. I mean, can I draw it also? Like, so let's say 4 is this. So 4 minus 1 factorial. And then, so that would be 3 factorial, which is 6. And how many same I can take? Let's say out of 4, 2 are same. So that would be like 2 factorial. 2 are same. And they are in, so clockwise, anti-clockwise, same. If I arrange them, then another 2 factorial will come up, okay? So that will become 6 by 4. Is it possible? 3 by 2. No, this
Sir, is
is
this 4 minus 1 factorial or 3 minus 1 factorial?
no. We have. So I'm about to take 4 items. So what I'm explaining is, let's say I have 4 items. Okay, let me take. Let's say I have triangle, and let's say I have square and triangle, something like. So I have 4 items. 4 items are there,
Okay, sir.
and I want to arrange in circular order. Okay, so since I want to arrange them in circles, so that will make it n minus 1 factorial. That is like 4 minus 1 is just 3 factorial, is just 6. Okay, so I'll just write directly 6 ways to arrange them. Arrange the 4 items. Now, the cases they are repeating or something like I have same kind of this. So what ways I can do? Let me draw another one. It's a triangle here, and square and square. Is there any another way? So I can draw like triangle, square, and then it's a triangle, square, and square. So I don't think so there is any other way. Okay, so any like 2 ways only. You can something. So I mean, see, this is becoming little bit difficult, but when you go,
triangle square.
Can this be like a triangle, square, then triangle?
Yes, sir. So square,
so
triangle, square.
triangle, square. So if you see, it's this one only. Okay, this one only. See, see what you did is, let's say you start from here. Okay, then you go square, triangle, the square. You reach here. So it's the same thing.
So basically, that does not matter from where you start. It's just the order
Yeah.
that matters.
Yes. It doesn't. That's what it is. Yes.
But can we do like first triangle and then square and then triangle and then square? Is it possible?
Yes. So it's this one, right? So square, then triangle, then square. So we started from here, square, triangle, square, triangle.
Okay. So it's possible.
Yeah, it's possible. So you are just telling me variations of this, okay, and different variations of this same thing.
So, sir, is it necessary to do the variation like in every way to do like how we can make it then like different patterns? Or so is it just like we need to just know that how many times we can do the arrangement?
Yeah, this is I'm showing you so that you can relate it. Okay, by either way, see, we are just gonna ask you how many ways you can do it. I
Okay.
mean, that's the only thing. And later on, when you will have the probability, right? Then you don't need to draw all of this because see here we have very small number 4 and 5. Maybe I can take two. This is the space I can show you. But later on, there will be like 19 items. Okay, so let me take. Let's say I have 19 items. 19. Let's say 19 kids are there in school. They form two circles, not concentric. So they're forming these two circles. Okay, and let's say 9 are here and 10 are here, something like that. Then how many ways you can arrange them? Uh, yeah, how many ways you can arrange them? Okay, so uh, yeah. So what's happening? See, one thing is I'm taking 9 here uh, and I'm doing 10 here. Okay, so it's not or. So you get that I need to multiply. One thing is clear, right? Uh, this is very important that or should come or and should come, something like that. So okay. Now how many ways to arrange nine kids is 9 minus 1 factorial, right?
Yes, sir.
Yes, sir.
8.
And this is like 10 minus 1 factorial. So this is like 8 factorial multiplied by 9 factorial. So you can maybe calculate it, but whatever answer is okay. I'm not doing that. So it will become a little bit difficult and difficult with numbers. So I can't now draw you. I can't show you with drawings. It will be very see the numbers itself. Let's say even this one number itself is very huge. Now they are become two. So it's like that. Okay, don't worry. So you don't need to draw this. It's just for the visualization purpose. Now okay, we did cover factorials and all. Yeah. See now what I did till now I did arrange them. I need how to arrange things. I will give you things and I'll tell you that arrange them, arrange n things. Okay. Uh, whatever condition, distinct, not distinct, circular, linear. Okay. So you know all the ways. Now I'll come to the next part that uh, how to choose things. Okay. So what is the difference from previous? That previously you had whatever items you can't exclude anyone. I'll not say that you five kids that I'll not selecting or something like that. I'm not saying you have to arrange all of it something, but now you can choose them. So these choices will come in handy when it's very real life implementation. Let's say you have cart. Your cart is there, okay, and you have like 5 items in that. Uh, let's say pen is there, a book is there. um what could be that? Let's say one mobile is there. You want to buy a mobile. Then let's say water bottle you want to buy. Bottle you want to buy. Then another thing you want to buy could be cup. Let's say cup you want to buy. So these 5 items are there, right? Then I'll say that okay, out of these 5 items, since your uh, budget is limited, right? So you can only buy 2 items. I mean, something, right? So don't go with the prices and anything, but let's say you have 5 items and you want to buy something limited out of it. Let's say choose 3 items or something. Okay. So how will you do choose or something? So that is called combination. Okay. Combination. Uh, See, I never arranged them. I never did anything. I just choosing it. Okay, this 2 item I want, I'll buy it. That's it. This 3 item I want, I will buy it. That's all. I'm not arranging them. Okay, so that is what called combination. Only choosing. So that is like let's say I had 5. Okay, so the formula of combination is like I have n factorial n
N minus half
Hello, hello. Am I audible?
Yes,
Yes.
sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Wait, wait, wait. Maybe I think I could
Sir.
stop them. Is my
Yes,
screen
sir.
visible or do I need to reshare?
No, sir.
Not visible, sir.
Okay,
No.
okay, I'll share.
No, sir, nothing is visible.
Okay. So yeah.
Now visible, sir.
So
It's visible
okay,
now.
so okay, I'll explain. So combination is you take this formula and we were choosing 3 items out of 5. Okay. So for that this we reached here.
Sir,
So
can you explain
that would
from
be
the
10.
beginning?
Okay. Okay, I'll explain. So we had 5 items. I wanted to choose 3 items. So formula for that is this combination. Okay, so 5 minus 3 factorial. This is like sorry, this is 3 factorial. R is okay. So that is like n choose R. Okay, n choose R. You can write this as NCR. That is what, and the formula for that is n factorial, n minus R factorial, and R factorial. Okay. So let's say 5 items are there, then choose 3 out of that. So that is like 5C3. And for that formula is 5 factorial, 5 factorial, 5 minus 3 factorial, and 3 factorial. And if you solve that, that is like 5 into 4 into 3 factorial, and 5 minus 3 is 2 factorial into 3 factorial. You can cut this. 2 factorial is 2 only. Okay, so that is 10. Yeah.
Hemant, turn off your mic.
Okay.
Sorry.
So okay, so we have 10. Okay, so that's how we choose. So choosing is very easy. Whenever we ask you choose this. Okay, so when we choose things, when you have more things, like many things, out of that take a subspace, or a, sorry, not subspace, a small set. Okay, small set out of it, from the universe or something like S1 or something. This will come handy later on, but this all things are choosing. Okay. Very uh, important thing. So how will you choose this NC? Uh, Let me take an example again. So go with it. Yeah, okay. Let's say I have, let's say school is there. Uh, there are uh, let's say 15 boys are there, and 10 girls are there. Okay, and I want to select one captain, from this. So I mean, for selecting captain, gender doesn't matter. I mean, this is just the data. Okay, gender doesn't matter. So how many choices I have?
25.
25.
Sir, first.
C1. Okay, C1. Choose one
Yes,
because
sir.
I want to select one captain. So that would be 25. You can solve this. So maybe let's say 25 factorial. 25 minus 1 factorial is 24 factorial, and 1 factorial. So if you can write 25 as 25 into 24 factorial, and now I can cut. I did it here. Same thing, but that would be 25, right? Now let's say same thing, same example. 15 boys are there and 10 girls. There is a group I want to form out of this. Okay, one group, uh, which is going to maybe some science fair or something like that kind of question. You'll have science fair they are going. Yes. Okay, so they are going there, and one group consists of 3 boys and two girls. Okay, let's say 2 girls. The group consists of this, and okay, uh, so you know that I need to choose 3 boys and 2 girls. So this itself explains multiplication. Okay, now how many boys are there? 15. Out of the how many I want to
15C3
choose? So
into 10C2.
10C3 into 10C2, right? This would be 15. Oh yeah, another property of combination I can give you is NCR is equal to NC n minus r. So we can maybe prove it. So let's say I have 5 things. Let's not take 5. I have 6 things, or 6, and I'm choosing 2 of them. And what I'm saying is 6c n minus r is 4.
4.
This 2 are equal. These 2 are equal. That's what I'm saying. We can see
Yes.
say n 6 factorial. 6 minus 2 is 4 factorial, and this is 2 factorial. Here it will come 6 factorial. 6 minus 4, 2 factorial, and that's 4 factorial, right? So uh, if you remember n minus r and r factorial, this was the formula. So if you write this both are same. Okay. Uh, so maybe you can use it here. See, 15c3 would be equal to 15c12, correct? And here
Yes.
it is like 10c8. Uh, so that would be like 15 factorial divided by. Is that so helpful here? I mean, I don't know if it's helpful here or not, but this also something you can do. Okay, so that's like 12 factorial into 3 factorial, 10 factorial into 10 minus 8 is like 2 factorial and 8 factorial. So this you can say like 15 into 14 into 13 divided by 3 factorial. So you had 12 factorial, right? Which you cut it with this. So that's it. And then here you can write 10 into 9 divided by 2 factorial, or just 2 would be also. So this 3 factorial is 6. And now what you can do is, let's say maybe you can divide this as 5 is a 15 and this 2. Here 7, this is 5. So you'll see you have like now 5 into 7 into 13 into 5 into 9. Okay, whatever this number is. So this is actually answer. You can use calculator and do it. Okay, so this is just another example
Sir, I
how
didn't understand
choosing.
this one, like sir, the one you just
Yes, sir. Could
explained.
you please explain the last part?
Sir, from the beginning, sir.
Okay, let's see. Let's see. I have 15 boys and 10 girls. Okay. I need to form a group of 5 people, 5 students. 5 students of group I need to form, which consists of 3 boys, which should consist of which should like and then 2 girls. This is the things I wanted to have in my group. So see, so total we have 25 things. Okay, 25 students. And if I do like 25c5 and do it, then what I'll get in this, I have 25 things. Out of that I'm picking 5, but that's not actually I want. What I want is I want 3 boys only. Now in this case, in this case, what is the incorrect case? Incorrect case is, let's say I have 1 boy, other rest of them are girls. Okay, this is incorrect. Let's say I have 2 boys and rest of them are girls. This all cases are coming in this choosing part. Okay,
Yes,
then
sir.
let's say I have 1 or no boy at all. It's a no boy and all this and something like this. Okay, so not there is no arrangement. This all cases are coming up. Okay, then like let's say this is b1. uh, then let's say this b1 b2. Now in this b1s also, b2 can come up, b3 can come up, b4 can come up. So this all arrangements are sorry, not arrangement, this all ways, different ways are there internally in this. So I can't do this way. Okay, so what I need to do is, this is short way I can't do it. So what I'm saying is, we have 15 boys, choose 15 boys, we have choose 3 from that, and I am doing out of 10 choose 2 girls. Okay, and we know from like addition and multiplication rules that and is multiplication. Okay, so this what shorted here. Okay, and this is the formula, like 15 factorial divided by 15 minus 3. So it's like r factorial. You can write 15 minus 3 as 12 factorial, and this is 3 factorial.
Yes.
This is like 10 factorial. 10 minus 2 is 8 factorial, and then 2
And the
factorial. Then you can solve this. So this is just solving. You will get this
Okay,
answer.
sir. I get it.
Okay. Yeah. So okay. See now we
Sir,
did
that
learn. Yeah. Go ahead.
this part I understood this part, but at the end you were explaining another way of calculating, right? Wherein
Yeah.
you were
See
saying that I did not
so
understand.
that so let's say I had this one, which is equal to 15C12. What I mean is NCR is equal to NC n minus R.
Yeah.
Okay, so this both are same. It might useful somewhere, but here I'm not seeing it. Maybe in permutation or not in this question, but it's same thing. But this both are same. Okay, just in case. Will later on learn something called probability functions and all, where this will come in
Okay, sir. Okay.
later on, very later on in the course. But just now I'm just putting it there.
Okay, sir. Okay.
Okay.
Thank
Yeah. Okay. So we did. Okay. So now what we did is we learned how to arrange things, arrange n things. Let's say, or let me write r things. Okay. So we learned how to arrange r things. That is r factorial ways. Previously, I used just n notation, and then I learned how to choose r things from n n items or n things, total n things. Okay. Choosing is that combination NCR. Okay, so this two both way I learned. Now comes permutation. So what is permutation? Just spelling correct. Permutation. What it is it is choose r things, okay, out of n, and so again and is multiplication. So and arrange r things. So I think you got the idea what I'm going to do. So this is NCR, right? And this is R factorial. That's why I wrote this way. So permutation is kind of uh, both the things I'm doing. I'll choose R things and then I'm going to arrange them. Okay. So choosing and arranging is like permutation. Okay. We'll take example. So if you solve this will get n factorial, n minus R factorial. This is R factorial, and I'll multiply that with R factorial. So this we can remove it. So just like n factorial divided by n minus R. Okay. This is permutation. So permutation we denote with P and we write like NPR. Okay.
So this can be done
Uh,
only if the condition is and, not or.
and
Like so
not or no.
like there will be.
Or will see whenever the question demands that select and arrange, then always it's going to be and select and arrange. Like
So only then we
you will
can use
never see.
permutation.
Yeah, see, you will never, I think you will never see a case where, will say, or anyone say that you had, let's say you had 5 books. Let me take example, okay? So I'll say let's say I have 5 books, history, physics, mathematics, maybe chemistry and biology. So there's 5 books are there. Now what you're saying is, one case is I select, let's say 3 books. This is one case, okay? And arrange 3 books. So this is one case. Another case you are saying, which is you will see why it's like kind of nobody does. Okay, nobody does that. Let's say I'm saying select 3 books or arrange 3 books. I mean like I mean see, you get it right. Either you do this, or you do that. I mean and another problem with this is what 3 books. Here I have 5 books. How will I know which 3 books I have to arrange? I mean this is very ambiguous. Okay.
Yes.
This
Yes,
ambiguous.
sir.
I mean, it's not possible, you can say. So which three books you are talking about? Here I know that I selected three books and I need to arrange that only, right? I do have three books in my hand now. Then I am arranging it. So that's possible. But here I am arranging three books. Which three books? I have five books. Ambiguity. So I can't do it. So this way it's not possible. So this only way is this one. Select and arrange. Okay. So now let's say how to select three books is 5C3, and I'll arrange them in three factorial way. Or you can say directly 5P3, which is n factorial divided by n minus r factorial. So this is like 5 factorial, 5 minus 3 is 2 factorial. So 5 factorial we did earlier is 120, and this is 2. So this is like 60 ways you can select and arrange. Okay. So
Sir, I have a question.
yeah.
Sir, here the arrangement of three books and the question is just like physics and chemistry are at the same place and no books are between them. So this will be also an arrangement or this is another thing?
No books in between. No books in between them.
Yes, sir. They are
So
always together, physics and chemistry. This is
yeah. Okay.
arrangement or
Yes, that is arrangement. Okay, I'll take that example as well. See, now okay,
okay, sir.
let's say I have same books. Okay, same I will take. I have physics, sorry, maths, chemistry, and biology. Now question changes a little bit, that they are saying that let's say chemistry and biology books should always come together. Okay, should always come together. And how to arrange? How many ways we can arrange them? How many ways to arrange? Just arrange. Okay, we are not choosing anything or something. Just arrange them. So since they are saying they should always come together, how to do that is I call them like HPM. Let me call this new item, or you can name them, or you can just say that this is group one. Okay, let's say this is G1 or something. You can call them. If there are multiple groups, let's say this group or something later on, if that is the question, you can group them in any way. So let's say I have this G1 now. Now I have how many items? Four items only, right? You can bundle them. You can say so now to arrange them is four factorial ways, correct? And see now, and this this is G1. Inside this G1 there are two things there. This C and B is there. I can keep them like B and C also. Like the question is just bundle them. We never talked about uh, order or something like this. Let's say this should come first or something like that. So that will be, and means two factorial. Uh, this two items, right? Two factorial. So that will be like 4 factorial multiplied by 2 factorial. Arranging them. Okay. Uh, so 4 factorial is 24, and this is 2, which will become 40. Okay. So whenever they say keep them together, the two persons should be seated together. Then you can always make them seated together like this, like seated together. Let's say the two boys are there, then you can make them seated to like this, and then you can arrange the rest of the boys something like this, right? So you have 6 boys, but you want to arrange them, and this two should be together. So you can arrange them in like 5 factorial ways, and then you can arrange them also like B2 and B1 or something. This arrangement is also possible. So you can say 2 factorial something. Okay. So whenever they say
Yes, sir.
club or something, you can do it. Yeah. So that is permutation. Okay. So see, if you go with ma'am's lecture, uh, she has done a different way of this permutation. So there is no combination covered in week 5. I have covered it. Just so I think that is to explain this part. But maybe you can go with her way of teaching and directly land to permutation and then go back to combination. Okay, so in that way, what we are doing is we are arranging the things Then we are learning how to arrange and choose. Uh, choose. And since this is a bigger set, right? So how to uh, do a smaller portion of that or something, right? So since we did earlier n factorial by k factorial, we learned this part. This how to do 5 factorial by 4 factorial. This is like this you can say np4. Okay, np no not 4 np1 np1. Okay, so that's why this thing came there. So yeah, so I think that's all that's there for concept wise. So if you have any doubt, I can explain it. I have still time. I'll take maybe one or two examples, otherwise, and then we can proceed.
Could you explain the
So
part where you
I think that's
select?
all right. Give me a minute. I missed anything. No, I did cover that. Yes. Okay, yeah, go ahead.
So can you suggest some books where we can do practice of these questions or something?
So we so okay, were you able to solve all the portal the questions in our portal?
I haven't tried yet, but I know that they like. But I just want
Yeah,
like sir, one way only, like complete questions, something like that.
Actually, I'm not sure about any books or anything, but you can try whichever it is the course book, right? The statistics or something, which book is covered in this course. In course page, you can course description or something, so you can go and try that book. But
Okay,
our
sir.
curriculum, like our questions in our portal, are really good enough. I mean, they are tough. Uh, Varieties are also there. We have already collected all of them since this course is running for, I mean, like think since 2019, so kind of 3-4 years, and we have really collected good questions, good amount of questions, all
Sir,
kind of varieties and all.
sir, so
Yeah.
do we need to order those books, or this one is enough? That's what you are telling. The lectures and practice assignments would be enough.
Yeah, lecture and practice assignment would be enough. Correct. You
Thank
can
you.
watch tutorials. So since tutorials are there, right, in every week, watch tutorial for week 5. That they are very good. I mean, all the
Yeah,
questions, how
yeah,
to solve them.
sure.
Yeah. So before seeing the answer, just think about this all things. Okay. So we learned how to select, how to uh, and how to select and arrange. Right. So always think which one is there. Which type of question is this? Because you'll not always listen or always not given in the question that do I need to do this one or that one. It's not very clear from that, but you'll get it like later on that how which part I'm talking about. Okay.
Yes, sir.
Yeah.
So
Go
could
ahead.
you explain
Some question.
the last part where you said that there are two similar objects, not similar objects, but two
Sure.
objects need to be
Sure.
placed simultaneously.
Yeah. Sure. See. Okay. Let's say I have. I'll take another example. Okay. Let's say I have. Mm, let's say I have 20 students. Okay, 20 students are there. Students, okay, 20 students. And let's say I say that they should sit in a row. So there is only one row available for me, okay, which contains 20 seats and all. And let's say I say that 5 students, some 5, okay, which I I can maybe since they are all distinct persons, distinct student, right? So S1, S2, S3, and something like that, which goes till S20. Let's say I say that 5 students, maybe S5 to S9. Okay, this 5 students uh, are sitting together. Okay, they should always sit together. So that is like a block of it. Okay, so if you see, let's say 4 students sit here, S1, S2 sit here, like and they can sit in different orders. This is S2, S1, S3, S1, S2, something. So this all orders are fine. Okay. And but the important part is we need one block, like this block is there. That since let's say SY that here, then S6, S7, S8, and S9 should always be together. Now they can also shuffle in between or something, like they can it could come like S5, S7, S7, S9, S8, and S6. Okay, something like this. So this all arrangement internally is possible. Okay. So how many ways to they can sit? How many ways this 20 students can sit? So we know that 20 students can sit in 20 factorial ways, but that is not the answer. Because how many groups we have? So we have like 15 students, and another like 5 groups. Okay, so for like another 5 students group, which is a group. Like I'll call it as G1. So you know that this G1 is contains 5 internally. Okay, so how many
And you can also say that
different?
the other the remaining ones are also another group, right? Like without.
Yeah, you can say they are group, but the problem
Yeah,
with
but
that
our
is
our filter is S5 to S9.
yeah, you see you can't say actually they are group, because see this is breakable, right? I mean, let's say S1 comes, then G1 comes, then S2, S3. But this G1, inside this G1, I can't go. I can't break it. I can't change it or something like that. I can't go in between that or something. But here they are separate things. So
So
total.
I'm
Okay,
saying, even the ones who are after S9 can come in the front or whatever. So that also becomes a group, no, sir? No, like by default, when you say that when you say that the 5 students are a group, so the remaining 15 become a default. Like, how do I explain that?
Yeah,
Individual,
they are
like
items.
they're individual.
No, see. Okay, let's see. See, I think more numbers, but let's say I had earlier 5 items, right? Let's say 5 items are there. Let me draw the books itself. Let's say H is there. I think math was there, physics was there, chemistry was there, and biology was there. Okay. So now what I'm saying is I'm grouping them. So let's say this two is a group. Now can you see I can't go in between? Now I can't. The only way to arrange them is HMPCB. Okay, or let's say HPCBM. I mean I can't go in between. But here I can. Here I can, or something. I can make it in, or it can start from CB itself, then like go HMP or something, right? So all this is possible. I Sorry, your voice is clearly. I can't understand.
So CV cells can be arranged in 2 factorial ways, right?
This yes, correct. This we can arrange it 2 factorials. So later
So,
on, if let's say
multiplying it with the total, right?
yeah. So currently we have 4 items total, right? Total, you can say 4. In this case, 4 things. So we'll say 4 factorial. Then this 2 are there, which is 2 factorial.
Got it.
Something like that. Okay. So here, let's say I took this example. Yeah, go ahead.
Yeah, so we are considering this like the group that we choose that as an element itself. Like that becomes
yes.
Got it.
Yes.
That's why we are saying
yes.
4
It did become
factorial and
element
then 2
itself.
factorial. Got it.
Yeah, correct. So I'm calling them as a G. Okay, that's it becomes element. So that's what it is. I have G one G, like grouping them one. Then this 15 students are there. So total I have, like earlier I had 20 total students, right? Then in this 5 students are forming a group. Okay, and 15 are just separate things. So total I had like 16 elements. You can 16 elements, and to arrange 16 elements, I can arrange them in 16 factorial ways. But this 5 guys can also arrange in between. So that is like 5 factorial. You can solve it this whatever answer comes. Okay. So that's how
Like,
you can do
first
it.
we need to add, and then second we need
So,
to
sir, just
multiply.
give me the general the notation, right? Like n. How do we represent it when we are calculating this?
calculating.
The general, the formula. That's what I'm asking.
Okay, so there is no. Okay, you can say, see. So what's happening is actually this is factorial only, factorial. But what's happening is like I have this bigger thing, and inside there's a smaller thing is there. So that's why we arrange them this whole thing as some factorial. Okay, so let's say I had like n items, and okay, I can make it. Let's make it. So I have like n minus r plus 1 factorial.
Right.
I don't want to bring this, but if you are asking, I can say that r factorial. Let's say these are r items. R thing form a group. Don't see go with formula. I would not uh, recommend this.
Okay.
Think logical
So
or
is
in
it out of
numbers. Okay,
instinct
that would
logic? Yeah. Okay.
yeah, instinct or logic. That would be much better.
Okay. Just show me
Yes,
the
sir.
book
The
example.
format
I
is
just
getting
wrote it down.
confusing.
Yeah. Okay. Huh?
Just show this. Put the slide up. Now I just want to have a. I'll just take a screenshot of it. Yeah. That's
Which
it.
were
Just zoom out. Yeah.
or okay
down.
or maybe I can upload this. If you want, I can upload
Sir,
this. You
am I
want
audible?
that?
That would be better.
Hello?
Yeah. Hello.
Sir,
Yes.
I have a doubt in this question, the one which you explained.
Okay. Which one? Student one or book one?
Yes, sir, the student one. Like, sir, first we need to see the, like, total number of students, and then we need to see which is, like, together, like, fit together, and then we have to,
Yes.
sir, add all of those students. Like, sir,
Yes.
can you go back to the question?
Yeah. Okay. Okay. See. Yeah. Okay. I can go, but I thought I could. Okay. See.
After 20 students, and one group is made with 5 students. So, sir, we need to first, like, subtract and then do 10 student and then 5 students separately, and then we have to do that way, right?
Yeah. Yes. Correct. Correct.
Okay.
Like this example, you can take it's a small one, right? So just I'm making it a bigger one of that. I mean, keeping two here. So that's like 3 plus 1, which is 4, and that's how this 4 came. Then this 2 can arrange itself, so that's like 2 factorial. Here I had 5 items, so I did 5. Okay. So
But I feel
some
your generalized formula also is correct. Now you were mentioning it. It was pretty correct.
yeah, it's correct.
Sir,
I know, but
Sir, but when
what happens?
there are sir, but there are two groups, then we can't use formula. Then we have
No, then
separate
see,
formula.
yeah. See, what's happening is, let's say I have, okay, I'll take another same thing. Let's say I have 20 students. Okay. Now I'm saying 5 are forming group, which is same as, so this is like group 1, and let's say another 3 are also forming a group. So this 3 are also saying that we'll also sit together. So this is like sitting together. Okay. So this also is sitting together.
Sir, it will be 13 factorial into 5 factorial into 3 factorial. By logic.
Yes.
So let's say I had 20 students previously. Then 5 said I'll form a group. So this 5 is a group. This 3 is a group. So this is I call G1. This G2, and then rest are how many? 12, right? 18. So 12. So this like I have like 14 items total. 12, 13, and so this 12, one item, then another item, right? So this is like 14 items, right? So 14 factorial. This 5 could arrange in between, so that is 5 factorial. This 3 can also arrange, so that's like 3 factorial. Okay. So that's how multiplication. So that's how you can solve. Okay. So I'll upload this PDF if you need it.
Sir,
Yes, sir. Thank you.
sir, I had a doubt. Sir, can we generalize like when are events occurring simultaneously and when they're not occurring simultaneously? Can we generalize it or something like that?
Simultaneously and not simultaneously. I mean, see, depends on question. But that is what it is, right? So let's say here we took addition rule. Well, let's go and see what we see in addition rule. See, uh, what I took is I took one root and another root, right? So um, so I mean I can go either this way or this way. So is it simultaneous? No, I mean simultaneous is I think different meaning. I mean then I need two people that one should go from six this route and another go from that route or something like that.
Sir,
And
can we
here
categorize it?
definitely not gonna happen, right? So simultaneous is
Sir,
something two or three things happening together.
sir, can we
So
categorize
can
it?
we also say that multiplication rule is like simultaneous rule and addition rule is like non-simultaneous rule? Can we generalize it something like that?
I mean, no, I don't think so because see, if you do that, then you will see many cases where this not happening or you'll miss that. So just read the question and see if they are simultaneous or not. I mean you are kind of true and okay. Let's see. Let's see. Okay, what you are mean by simultaneous. So earlier we took example that I need to choose five. I need to choose five students. This example we did out of I don't know 15 boys were there and 10 girls were there. Okay, and I'm choosing three boys and two girls. Okay, so this thing's happening simultaneously. You can say that, right? So here I yes I'm using and all. This thing is happening simultaneously. But what could be a different one? Uh, I'm choosing three boys. Uh, and no, I'm not seeing it, but you can say this is actually happening simultaneously. Yes. So, uh, but there are actually another cases which is multiplication is there and is there, but it's not. I'm not sure. Okay, the simultaneous part. I need to think because I never thought about this part. I'm not sure. Okay, I can't make a judgment or statement about this. But this could be true. Okay, I'm not making it straight.
Sir, we can easily
I,
identify this thing by just seeing the question, I think. If we practice
yeah,
some
yeah,
questions.
yes. That's what I do. I mean, I don't generalize too much, so I never did it, so I can't say
Yes,
anything.
sir.
So, but if you read a question, you can do it. Okay,
So, sir, we
I'm not
can't
generalizing.
categorize it. So, like
Uh,
audible, non-audible, something
yeah,
like that.
maybe we can. I am not sure that much about, but you can read a question and then maybe make a judgment that is it a simultaneous or not.
Okay, sir.
Okay, so yeah, but there are two three things which are important. If I just recall this part, see, this is the whole crux of this today's I guess session that if there is or when two things can happen separately, that is like or when we add, then when we have to do one thing and also other thing, that then I kind of multiply it. And if I have n items, distinct n items, then I use factorial to do that. When they are not distinct, then n factorial by uh, g1 factorial g. So this then g1 and g2 are similar, okay? Like balls, red balls, blue balls, something like that. So we can take example. Circle is that, and you can do n minus one factorial way, and then you need to see if it's equal clockwise and anti-clockwise or not. Then you can divide it by two. Okay, if they are same both way, clockwise and anti-clockwise. This I don't know if this is covered or not, but I am telling you here. So, and this part is just the question. Combination is choosing. Okay, whenever you listen here, choose this, choose that, select also there. Another term for that. Um, I don't know if any other terms are there, but if you see here this part, see this part that is combination. When there is like choose and arrange, that is permutation. Okay, permutation. So let's see. Well, we can maybe solve few example. I can think of something. let's say I have 4 red balls. This is red ball. Okay. I have 5 blue balls, 3 white color balls. So white, I am taking white. Now, what we have to do is we have to uh, hello. Hello. Hello.
Abhijit Kumar.
Okay. So okay, let's say I have this. This is the set. Okay, or this is the whole thing I have. I want to select mm, 2 red balls. This is my select part. Okay, so yes, I'm making very clear here, but you might never, you might sometimes see select is there, but it's not visible or something. Okay, so I need to select. I want to select another things in which 2 red balls are there. One maybe let's say blue ball, and let's say 3 white balls. Okay, so something like that. So what I need to do? See, I need to select 2 red balls and right, and I need to select 1 blue ball, and I need to select 3 white balls. This part, if you are clear about this part, then this is just a piece of cake. Okay, you know that this is given, but this is the important. You should use or and, because you know that, see, I need to choose red balls. So let's say this is my uh, bag or something. I choose 2 red ball at a time. I'm also choosing simultaneously, you can say, or okay, I am choosing 1 blue ball as well, and also same time, at the same time I'm choosing 3 blue balls. So this and right, I'm not I'm not saying that I choose 1 2 ball, 2 red ball, or I use 1 blue ball. This is not the case, right? This is like or case, where they are in different basket or something. So okay, so if this is the case, then how to do that? So okay, I have total 4 balls. From that, I need to choose two, and which is multiplication. I have 5 balls, and I need to choose one, and okay, and I have 3 white balls, so I need to choose 3 from them. Okay, is this correct? Am I missing something?
No, sir, correct.
Okay, so it is incorrect. Okay, I'll tell you. Okay, sorry for that, but I always said the distinct object. Okay, distinct object. Now, if you see, whenever balls and something like cubes or something, I don't know, colors comes up, so then you know that this, let's say this ball and this ball, they're same, right? I mean, how would I know that this is different than this? There's no
Yes,
way
sir.
I know. So this is same, right? So I need to do what? Uh, uh,
Yes, sir, the
uh,
formula which you have written at the top, G factorial into G factorial, right?
yes, yes. So I need to divide it by 2 factors, correct?
Sir.
And this is I have only one item, and this is like uh, yeah. Okay, I'm choosing or selecting.
So I
Shall
think we
we
should.
use it in the case of arranging and arranging digits, right?
Sorry. I think.
So
Yeah, I
there
think
should be
I need.
seven. I think there should be seven C2. We are taking from
No,
n
wait.
balls now, and there are 4 plus 5. We have to take the total balls, I think.
So I'm choosing 2, and
12
I'm
C2.
choosing 1. No, that is no. See, that's 12 C2. Then
I
no,
don't think
we
it
have
will
12
12
balls
seat.
definitely, but I need to pick only 2 red, right?
Yes, sir.
So yes, so and I need to pick this, and I need to pick this. Uh, 3 balls. So Okay, there is one way to do that. And actually they are same or different. Does it matter? Distinct or same? Okay, sorry. I think I messed up with that part, and this is actually this is correct. I I also you will also make think this different, but in choosing in choosing doesn't matter. Uh, Shape, size, nothing doesn't matter. But if it was about arranging also, okay, then choosing and arranging, then you know that this red ball and this red ball I'm arranging. It is let's say I'll give number or something. Then it's the same as this also, right? That one and sorry two and one. I mean this arrangement. But here I'm not arranging anything. I'm just choosing. So this is correct actually. Okay, not making any mistake. This is correct. It's good. Yeah, I made a mistake and then I resolved it. So
Sir,
you know that this mistake happened.
sir, in the
Yeah.
first case, when we're choosing, the order does not matter, right?
Yes, order does not matter. Order does not
And in
matter.
the second
That's what.
case, uh,
No, we are just choosing, right? We are not arranging them.
yeah.
This is the bag.
And in the
I need to
second
just.
case, yeah, okay.
Yeah. Yeah. See, if I tell you that I have this, then arrange them also. Choose and arrange something like that. Then I need to uh, do something else. So that will be like you know 4P2 um, and 5C1. So basically that's what it is, right? See, if you see 4C2, that is n factorial n minus r factorial and r factorial, right? And what I'm saying is divide whole thing by r factorial or whatever to r. So in this dialectic, so r factorial. So this will or multiply uh, this is 4C2, then I need to arrange them. Okay, so this is choice. I can arrange them in r factorial ways, divide by uh, 2 factorial or something, right? Okay. Okay. So I got the point. See, okay, choosing and arranging. If I have this question, okay, then okay, then I will first choose it. Okay, so choosing is very easy. 4C2. Arranging is I have since two item, I can arrange them in 2 factorial ways. Correct? And since they are equal, when they're same, so I can say this also. So if they are not distinct, then I need to divide it as well, right? So this is my arranging part. It's my arranging part, and this is my choosing part. Okay, choosing part. So I'm kind of deficient. So this is actually 4C2 into 1. Well, it will not change. It will not make any change here, but maybe it could somewhere. Okay, not in this case. So that's why I keep them different. Like choosing is a different thing and selecting is a different thing. Like okay, this is choose. It is arrange, and in arranging we saw this when we have not distinct things and all. Then what you can do. Okay, so yeah, choose and arrange, right? So arranging we did learn it separately how to arrange it, right? Choosing we learned separately. So sometimes this logic actually helps that you are first let me first choose the thing. Now I have all the items in my hand. Now let me arrange it. Okay, so that could help in few questions. So arranging has it's all things, right? How many ways to yeah. Okay. It starts from here. Question we took. Arrange and distinct ways, then not distinct, then I do this. So if I don't have two red balls are coming together and I want to arrange them, then I'll go with this way. If they are in circular way, let's say I say that Yeah, okay. Let's say I have 19 students in a class. Choose 9. Okay, choose 9 and form a circle. How many ways? How many ways? Possible or something. Okay, you got the question. So basically, I'm not going too much grammar or anything. So 90 students there. I need to choose 9, and I need to form a circle. One circle. Uh, form a circle. And how many ways are possible? So you got that I'll choose first, and then arrange it also. Okay, so I know that if there is circular thing, I can arrange in n minus 1 factorial ways. Right? And I know that since students are going to be different, like they can't be clockwise and clockwise different, same energy. That's not possible. So okay, let's see this choosing part, which is like 19C9, and is multiplication, and to arrange them is a n minus 1 factorial. Correct? See, choose this you can't do with NPR. Okay, then your answer would be like 19C9 and multiply. You will multiply this for 9 factorial, right? Sorry, r minus 1 r, because we'll have 9 items, or I can write 9 minus 1 factorial. Okay, so you can't do this. This will be incorrect. This is the correct way. So selecting and choosing differently sometimes will help. Sometimes you can directly put NPR, and then you but then you know internally that this is what you are doing. This is what you are doing. Okay. I hope this can explain. Yeah, okay. Okay, let's say I have 20 members. 20 members are there. Okay. Uh, they go into meeting. They go into meeting, and they handshake only once. Okay, only once. With another. So with another. Get it? So in how many ways? How many ways they can do it? Now see, now what mistakes are possible is, first, there is no nowhere written you should choose or arrange or do both, okay. I mean, do both, choose and arrange. If I C and A, okay, something like nothing. It's there. The question is very simple. Like 20 members are there, they go into meeting, they go, okay, they do handshake only once. That is the once. Okay, that is the only information I have. With another. So like, of course, I'll meet somebody, I'll handshake with him, right? And how many ways they can do it? So that is a very simple question. But there is nowhere. I am audible, right? Uh, just okay, check. Hello.
Yes,
Audible,
yes,
audible,
sir.
audible.
Yes, sir.
Okay,
Yes, sir,
okay.
audible.
Yeah. Okay. So in this case, there's nowhere written that is to choose or arrange or do both or something. That's right. So this kind of questions you will come across that from the question itself, you will not see these words, this part, right? Or maybe select or something. This will not be there. Then you kind of think what is this scenario is picturizing or something like that. So let's see. This P1 is there. He'll go and do handshake with P2, P3, and how much is there? Okay, so all of them till P20. Okay, so he's doing this. How many handshakes are there? 90.
Yes, sir.
Okay. Yeah. Then let's say P2 comes into picture. He goes and he can't do handshake with P1 because he already did. Okay, here we did it. So he can't do it with P2. So it will start from P3, right? Then P4, like this P20. So that would be 18. Uh, then then let's say third person comes up, then he can't do handshake with 1 and 2. He can only do it with P4. Like that it goes till P what P P20, right? So that would be 70. So uh so what is it? Like I need to now what I need to do? Multiply, add, what should I do with this? So right, I'll add till 1 or something. Yeah, 1, right? P19 guy will only do handshake with P20. So what is this? Should I add them, multiply them, these numbers? So this is the right answer actually. You can go direct math. I'm not using any permutation combination, anything. Just this is just pure logic. You can just do something with this numbers from 19 to 1 and you have your answer. But what is it? Multiply, add, minus, what will you do?
Sir, addition.
Okay. Yeah.
Sir,
Okay.
addition.
Yes, addition, right?
Yes,
So
sir,
this
because
is pure. Yeah. Yeah, go
it's
ahead.
not dependent on others, so we can add them.
Yeah, correct, right? This is just the logic, right? You'll just add them. So that's like 19 plus 18 plus 17 and you go till 1. So this is like,
So that is the
I
number of
think
handshakes that we are calculating, yes, sir?
yes, this number of handshakes happen, yes. Okay, so you see that is going to be 19 into 20 divided by 2. So that is like 190. Okay, I mean this is if you don't know that's okay. You can add them, but that is n into n plus 1 divided by 2. So this comes from series APGP. You have learned somewhere that's okay. Okay, now yeah, so this is just a pure logic I used. But what can I say with permutation combination? What I'm doing there? Uh, can I say I'm choosing 2 person at a time out of 20? Out of 20, I'm choosing 2 at a time, and uh, then they are doing the handshake. I think yes, right? That's what it is. So if you see, that is like 20 factorial 20 by this is like 18 factorial and 2 factorial. Okay. So if you write 20 into 19 into 18 factorial or so this will cut out and so this is like here you can do 10, right? So this also 9. So same we did this way and that. So this is choosing something. So but it's kind of hard to see which one should I do, why you should combination or something. So sometimes you will come across this, but that's what will come with practice, and you do more practice, you know that which one to. Yeah, so
Sir,
that's all I think. Yeah. Yeah,
Sir,
go
in
ahead.
last step, I have a doubt.
Just yeah, go ahead.
Sir, how can we arrange?
Arrange to whom?
Yes, sir.
Arrange to whom? We don't need to arrange them, right? I mean, just choosing is enough. I mean, we don't need to do this part itself is the question. Yeah.
Okay.
I mean, see, arranging is, let's say you have these items and you let's say A, B, C is there, and you want to arrange them, right? A, B, D, let's say then A, C, B. This is what arrangement is about. Now let's say in handshake, what happens? P1 is there. He do handshake with P2. Then let's say P1 is there, then he do handshake with P3. I mean, there's no arrangement also. Like let's say P1 was handshaking with P2. At the same time, P3 was kind of same time, doesn't matter though. Is doing with P4 or something, right? But the question is only once they should handshake or something, right? So uh, you can see we are out of 20 are there. We are choosing two people to come in front and choosing it, and they do handshake, right? So that's what the simple logic is, and this will come out to be 190.
Okay, sir.
So yeah, so that's all for today. Yeah, one more thing. Let me take one more example is when repetitions and all things happens, and maybe you can make a mistake. So let's say I have this lock. Okay, this lock is there. Uh, so this is a 3-digit lock, and in this 0 to 9 can come, this 0 to 9 can come, and this 0 to 9 can come, right? So how many possible combinations are there?
1000.
Right,
90.
1000. So yeah, so
Okay.
what I did is I'm doing 10 and 10 and 10. Okay, so that's like multiplication. I mean, the
Yes, sir.
possible ways to put here is 10. And see, at the same time, I mean, I'm not saying that you can say simultaneously. This is okay. Same time, I'm putting another 10 as well, right? I need to put something here. Otherwise, this lock will never open. As a 000 is also a possible combination, right? 001. But I need to put 0 or something here at a time. So that's why I'm using n. Okay, so that is like you can say 10 power 3 or something. Okay, multiplication.
Excuse
So
me,
this is
sir.
where repetition
Sir, what
is
if
allowed.
Sir, I have
there
a
will be no
question.
repetition?
Sir,
Okay. When repetition is not allowed, right?
Yes, sir.
Yeah, go ahead. Go ahead.
sir, I have
Another
a
question.
question.
Yeah.
If these three locks are different, such as first lock is separate, and second is separate, and third is separate, then there should be addition, na?
They are separate. So you are saying I have one lock, which is lock 1,
Yes, sir.
and then this has 3 things. I mean, so these are not.
No,
I mean, these are
not only one
this
digit lock.
okay. 1-digit lock is there.
Yes, sir.
And I
Three
need to open
different lock
this. Yeah,
with one digit.
then correct. Yeah, I'll just do so. This can be opened with 10 ways, right? Only 10 possible.
Yes,
Then this
sir.
also 10 possible. This 10 possible. So that will be 30,
Yes, sir.
right?
Okay,
Any
sir.
something. 3 locks,
Okay, sir.
different numbers could be possible. Yeah.
Okay, sir.
Okay. So what if repetitions are not allowed? Okay. So that case would be yeah. So let's say I say form a number using let's say 1, 2, and 3. Okay. And I'm saying that repetition is not allowed. Basically, what I'm saying is, let's say 1, 1, 1 is not a possible scenario, or 2, 2, 2 itself is not there. 3, 3, 3 is also not there. This is very small example, but or even let's say this is also not possible. 1, 1, 2. Okay, because I'm repeating here. So all the numbers should be different, right? So if you see, okay, let me choose different set of numbers just in case, 8, 9, maybe let's take 6. Okay, just one digit. Take it because 1, 2, 3 will make difficult to access. Now, see, I have 3 positions open. Anyone can go here, right? All of like let's say 8 can come here, 9 can come here, 6 can come here. So how many ways I can put it? So all the 3 are available to me positions. Then at this position, I have 2. That is 1. So this is actually factorial. Okay, factorial. Repetition not allowed. So
Excuse me,
if
sir.
you see some, yeah.
So by using this example only, what if we want to find the number of combination? If the situation was there that 6, 9, or 8 would be in one's place, then how we will
In
find
one's
the
place, okay.
combination? Then how we will find the combination of numbers?
You're saying 6
If
or
yes,
9
sir,
or
if we
8?
are putting
Okay.
any, if we are putting any of the number from 3 in one's place,
Mhm.
then how we will find the
Uh,
combination of numbers?
At one's place, any one.
If
Okay,
one of the
so
places
so
are
let's say,
For
locked.
example, 9. For
okay,
example,
okay,
digit 9 is in the last blank.
okay,
Then
okay.
how we will
So
find the
let's say 9 is
combination?
here, right? 9 is here.
Yes.
Okay.
Yes, sir.
Now I have only two choices, either 8 or 6, right? So I write like this or write like this. So this is a kind of, you can say 2 factorial. This is 2 factorial or 2.
Okay, sir. Then 9 we have not
Uh,
counted.
yeah, yeah. So this will become difficult when we have, let's say, 5 numbers, and you can say, let's
Yes, sir.
say
That's
9
what
is
I am
fixed.
asking. Yes, sir. That's
9 is fixed here. Then the 9 is fixed, right? So how many positions I have? 4, which changes. So that is like 4 factorial.
okay.
Right? Some number will come here. Let's say 8, 6. I'll add 4, 5, and 4 or something, right? So now this 4 numbers are there. They will change in itself, like maybe 8, 6, 4, 5 is there, and they can change itself. So this all will 4 factor. Okay. The only problem you'll face with numbers is when 0 is in the picture. Okay, 0.
And sir,
Since you know,
what if we have a situation that repetition is allowed in this example only?
then
So that we can put
then you can,
9 digit
okay,
anywhere.
yeah, yeah. Then so let's say repetition is allowed, right? Okay,
Yes,
see,
sir. In this one.
I have this 5 number. You are saying 9 should be here, and let's say repetition is allowed now. Okay.
Yes. Yes,
So
sir.
so it doesn't matter what I kept here. I only have 4 positions open for me, which changes, right? So
Okay.
see, I have 5 numbers. I can put any 5 here. Correct.
Yes.
Here also I can put any 5 because repetition is allowed. And
Yes.
here also I can put any 5, and here also I can put any 5. So that will become 5 power 4.
Okay, sir.
Okay.
Okay.
Whatever it is.
Thank you.
So yes. So okay. So only problem you will face in this numbers is be careful when 0 is coming into picture. Okay, because let's say uh, let me take 8, 6, 5, 4. Let's say 0 is there. Okay, this 5 numbers let me pick, and I want to arrange them, or and how many ways I can form 5-digit number or something. That's my question. How many ways I can form a 5-digit number? So see, I'm not doing any choosing or anything. But choosing will come. Let's say if I have 3 something, I have 3 only. Then choosing will also come. But what I need to do is I only need to do arrange here for now. You can say kind of arrange or something, not choosing. Okay? Yeah, and let's say repetition is not allowed. Okay, repetition not allowed. All right. Okay, so then see, in this case I can't put 0, right? Then this number will not become 5-digit. This should be 5-digit. I can't put 0 here. So how many options I have here? 4,
Only
right?
four, sir.
Right. And
Only
in this
4.
case, how many options are there? 4. Again 4, because now 0 I can put here. But whatever number I kept here, let's say 8 can come here, 6 can come here, 5 can, and 4 also. This 4 possible. But uh, here whatever, let's say I chose 8 as the part, then I can't keep it here, right? Whichever it is. But rest all can come. So 0 and which are here, and rest, right? Whichever is here, except that. So rest, I'll let rest because I'm not sure which one to come. Then 3, 2, and 1. So it's like 4 into 4 factorial. Okay. Uh, Repetition is not allowed. If it was allowed, then I can say 4 into all the 5 can come here, all the 5 can come here, all the 5 can come here, and so
5
like
to the
this.
power 4. 4 into 5 to
It
the
is
power 4.
4 into 5 power 4. Okay. Yes. Solve it. Yeah. So yes. And sometimes you'll come across properties of something. Like let's say how many numbers will form which can divisible by 6 or something, divisible by 6 or something. This kind of properties can come up. So you have to see, something like a number. If a number is okay, properties of 6, like say a number is divisible by 2 and 3 and divisible by 3 or something like that. So this all properties might help sometimes. Okay, so if I had an example, I would have solved it. This. Okay, so is there anything else, or we can maybe close this?
Sir, when we will having doubt session?
Sorry?
When we will having next doubt session?
Probably tomorrow there is session. I think there's another session tomorrow, and then on Friday we'll have regular that solve with us.
Okay, so can we ask doubt related to that assignments?
Doubts related assignment. Yeah, next class you can ask it.
Yes, sir.
Next class. So in solve with us we do that. Yeah.
Yes.
Okay.
Hello, sir.
Give me 2 minutes. Okay, I'll be back. Yeah, hello. Yeah, go ahead. What doubt you had? Hello.
Hello, sir.
Yeah, hello.
Sir, eh,
Yeah,
hello.
go ahead. Yeah,
Hello.
hello. No,
Sir,
I'm not.
जो
Hello.
lecture. Hello.
Yeah, you are audible to me. You can
Yes,
ask
yes.
the question.
सर जो PDF है लेक्चर का वो कहाँ मिलेगा?
I'm not sure how to give it to you, but I think we'll keep in supplementary content somewhere. Okay.
सर रिवीजन
We'll keep in
लेक्चर
supplement.
सर रिवीजन लेक्चर 3 और 4 का PDF तो नहीं वहाँ पे मिल रहा.
The revision session का PDF. Yeah, I think that's not there. I mean, this PDF, I'm just sending it. I'm like, I don't know. Do you need that as well? That PDF? Or you can
Yes.
maybe refer to. Okay, so I think I'll ask how to put this PDF to you. I'm not sure how to do that, but I can I can tell you that this PDF will be available to you. I don't know about other PDFs. Okay, how to do that.
Thank you, sir.
Thank you, sir. Have a nice day, sir.
Okay. Okay. Then I think
Hello,
we can
sir.
close it, right? Yeah.
Hello,
Hello.
sir. Sir, I not
Yeah. Hello.
understand grand assignment question third and fourth, sir.
Grand assignment.
Yes, sir.
Then third and fourth, week 5.
Yes, sir.
I can't give you the answer for that, but
Sir, idea for that question.
yeah, sure. Okay. Let's see. I'm not sure though. I can give you. You just graded assignment. Which one? This one. This one.
Yes, sir. Third and fourth.
But our questions are similar.
Yes, sir.
Or different.
Different.
Okay, third and fourth.
Information same. One question is different.
Okay, third and fourth. Okay, Jai bought a new car in New York. The license plate can be created with this alphabet. Okay, and numbers as well. Okay, can I just select a normal license plate or a VIP license plate? So now, okay, so now they're saying that they're like VIP is there, and then like what else? Normal is there. Okay, and then they're saying that Universal begins with 3 alphabets. Okay, 3 alphabets followed by 3 numbers. So, okay, the 3 alphabets, something. Okay, I'm just writing A for alphabets. Then there are like 3 numbers. Okay, so let's say there's numbers. So there's 3 numbers. It be anything. With repetition is allowed. Okay, so the VIP license begins with 3 alphabets followed by 3 numbers with repetition. So you can do repetition. The normal license plate begins with 1 number. Okay, begin with 1 number and followed by 3 alphabets. So 1, 2, 3. So this is 1 number. Then this is alphabets. You have to write 3 without repetition. Okay, in how many ways can he select VIP? So I think this is very easy, right? You begins with 1 number, 3 alphabets. Okay, this fourth thing here, and then here this thing. So it's very easy. It's repetition is not allowed. Repetition is allowed here. Here it's not allowed. So when you have repetition allowed, what you'll do? Uh, you write in powers, right? I mean, like, let's say this
Yes,
5 numbers are there. So 1, 2, 3, 4, 5, 6, 7,
6 to
9,
the
9 thing and 9, something like that, right? And then you have again 9 and 9. Like sorry, 10 numbers. Sorry, not this. 9 3 times, and then later on like tens will come, right? Something like that. So this way, something. So in how many ways? So see, they are saying either this or that. So this or, right? So you know that you need to add them.
Yes, sir.
But that much hint I can give you. I think that you can solve now.
Okay, sir. Thank you, sir.
Okay. Okay. Yeah. So we can close this then. Okay. Okay.